Hello everybody, and welcome back to another KTaNE module tutorial, this time on the module Tangled Wires. So this module will present a 4x3 grid of squares with wires interweaved between them. Our goal is to untangle these wires by getting an input directly connected to an output with no wires in between. So say, like this black wire here. This would be considered untangled. Once you get all four wires like that, I'll just show right here, the wires will become selectable, and you will be able to initiate the solving process to solve the module. The only piece of edge work we'll need for this mod is the serial number, in this case Quebec 84 Lima Romeo 3. So, the main difficulty of the mod comes not from the solving process, but from how to actually untangle the wires, because by all means this is a puzzle mod. So the majority of this tutorial will be covering how to untangle the wires and how the module works. Speaking of how the module works, how does it work? So pressing one of these orange pegs will swap the contents of the two squares adjacent to it, as well as the inputs if you're pressing the top buttons, and the outputs if you're pressing the bottom buttons. This is just a consequence of swapping the contents of the square. As you can see, blue and black swap, yellow and red swap, blue and black swap down here, yellow and blue swap down here. And pressing these will also add 1 to your move count. Pressing this green button will swap only these two inputs and nothing else. And that will cost, as you can see, 5 moves per press. So now that we know how the module works, the solving process is a bit more complicated. This green peg that I talked about that swaps the inputs will only need to be used at most 1 time per module. But for the sake of simplicity and explanation, I will be using it multiple times and will provide cases where it's better to just use the green button than trying to figure out how to do it. So, speaking of which, there are only 5 real cases you need to worry about on this mod. But before I even get into that, I should probably explain what I'm actually doing to solve the module. So the basic solving process for this, because we want to get all 4 wires lined up, is first we want to just line up one wire like this, and then move it to the side, and then do the same thing for another wire like this, and then move it to the other side. By the way, you can move an already aligned wire to the side by just pressing the top and bottom buttons of the same column. And then after those two, we will be left with one of the 5 cases in the middle, and you can just solve it using the method I tell you. So, okay, the actual methods, or the actual cases that you will encounter when solving the module. So there are going to be 5 total. There are 3 that don't use the green button, and then there's 2 that do use the green button at least once. Well, only once. There will never be a case where you have to use the green button more than once to solve a wire. So I'm just going to be telling you how to do it with 1 or 0 presses. So to start with the 0 press cases, we have this blue wire here. This case I like to call the bracket case. It's where the top and the top row and the bottom row both have diagonals for that wire, and the middle row has a vertical straight line. Once you have this case, you want to, say you have it like this, you want to align the input and the output on the same column using the top and bottom buttons, like so, and then press the middle buttons in the direction of the input and the output until the middle is aligned with them, like that. That's one of the cases. Another one of the cases Let's see if I can find a decent example. Okay, right here. This is a decent example. So the second case is this case where the top and the bottom both have vertical lines and the middle has a diagonal line. In this case, you would press either the top or bottom buttons to just immediately solve the wire. And the final case for no green button is what I call the zigzag case. It's when all three are diagonal and going through a dot in the same column. So in this case, as you can see, this red wire is going down right, down left, down right, in the same column. So in a case like this, you would press the middle and the top or bottom once each. So in this case, I press the middle first and then the top, and the red wire is formed. So that's all of the cases without the button. Now we talk about the cases with the button. So our first case for with the button is very similar to one of them without the button, but instead of the diagonal being in the middle, the diagonal is at either the top or bottom, and the other two are vertical. This case can be solved by simply just pressing the green button, and then it'll turn it either into a solved state, or if it's on the opposite side, it'll turn it into the bracket case, which you already know how to deal with. The other case with the green button, let's see if I can find one. No, not that. I'm trying to... Let's see. No. I'm solving them too easily. Ah, this is the other case, where you have two diagonals and one vertical, but the vertical is either on the top or bottom and not in the middle, in which case you would also press the green button and it'll turn it into one of the cases you know. Either this case, if you press the green button when the diagonal portion is adjacent to it, or if it's down here, opposite the green button, it'll turn it into the double zigzag case, which you know how to solve as well. And then those are the cases for the first two wires. And then those cases will retain for the middle here, except the middle will look different because it's doing it at two wires at once. So the middle will always be one of those 5 cases once you solve the first 2 wires. And so you just solve it as you would the others. So we get a wire lined up. We get another wire lined up. And this one's the double zigzag case. And then we'll do it again. Get one wire lined up using bracket. And then another one using one of the green button cases. And then we have the same case. This one we already did. And finally, I won't worry about it. So now that we've actually untangled the wires, we can get to solving the module normally. Let me just do this. Okay, so to actually solve the module, now that we have done the wire portion, so the reason those strategies I gave you, is mostly to reduce the move count as much as possible. Using the methods I told efficiently, you will be able to get the wires untangled in 30 moves or less. Most of the time. I'm pretty sure it's like 99% of the time. You'll almost never have a case where you go above 30 if you're efficient with it. But that's because these moves directly impact how we solve the module. So we begin with the first digit in the serial number, in this case 8. And we're going to repeat these bullets. These 3 bullets. We're going to repeat them an amount equal to the amount of moves divided by 5 rounded up. So in this case, ignore this. So we have 12 moves for this module, so if we divide that by 5, we get 2.4. Since we're rounding up, if the number ever has a decimal, you go up to the next number. So in this case, 3. So we're going to be repeating these bullets 3 times. So that equation set up earlier was actually how we're going to do it. So the bullets say to add the last digit of the serial number to the number. So we're going to do x plus 3, where x is going to be our previous number, and then multiply it by 2, as said here. And if the number is greater than 500, we're going to divide it by 10 and only take the integer part, which means chopping off the last digit. So if it ever goes above 500, chop off the last digit. So let's do this example with the 12 move one. So we're starting with 8, so x equals 8. So this is our first iteration, is 22. And since we're doing it 3 times, we need to do it 2 more times. So we plug in 22 to get 50, and we plug in 50 to get 106. So that's our third time, so we stop and take our output, which is 106. We take the last digit of our output and use that to determine which wire to cut. In this case, 6 is cut the red wire. Boom. And the module is solved. So I'm going to use this case where I did 80 moves to demonstrate another rule, which is if the amount of moves is greater than 60, you will do 12 repeats and no more. I guess this is just so that the module can't really scale infinitely or whatever, but it just means that 60 is basically the maximum for the calculations. So you could only do it up to 12 times. So we'll do the same process 12 times. Starting with 8, so that's 1. 22 is 2. 50 is 3. 106 is 4. 218 is 5. 442 is 6. But the number is above 500, so we now cut off the last digit. So 89 is 7. 184 is 8. 374 is 9. Cut off the last digit. 75 is 10. 156 is 11. And 318 is 12. Since we're cutting off the last digit, our last number is 64. So our ending number is 64, which means we are cutting the yellow wire. And we'll do it one more time. I'll go ahead and just solve this one from the beginning. So line... Yeah, there we go. Line this up. And then line this up. And then boom. And one thing I will mention, whenever you're doing one of the green button cases, you'll always want the wire to be aligned in the center 2 columns. Otherwise, the green button thing won't work because the green only swaps the second and third input. So in this case, we have 26 moves. So 26 over 5 is 5.2, so 6. So we're doing it 6 times. 1, 2, 3, 4, 5, 6, 89. So red wire. Boom. And that's tangled wires. I hope this tutorial did it justice. It's kind of hard to explain how to do this without just, it's intuitive. Because a lot of these cases feel intuitive once you actually know how to identify them. In terms of, like, creating the cases, that's very case by case, and is just going to have to come with a little bit of practice. I can't really explain much more than that. But otherwise, thank you for watching. I hope this was a good tutorial and it helped you a lot.